I come in today instead of Zoom, just for fun. Just use your path and then I'll get on.
Yeah, I'm about to go to the beach. I've been so long. Been recently?
No, the last time I ever, like 5 years ago, the last time I've been to Corpus Christi.
I've been to the river a couple times. Honestly.
In a river?
Even in a river. I know it's impossible, but
No, not even necessarily. I've seen like dolphins and other stuff like rivers, but only when it's like sort of flooded.
Yeah.
They come in.
no, of course, that is possible, yes, like, the bull sharks will swim up the river, and they can survive a little bit of fresh water, so that is a real, terror. But no, I'm talking about like rivers here in Texas that are spring fed and not connected to the ocean. I guess it's a fear of not being able to see, is that your feet, that type of thing.
I actually have the same fear. I thought I was the only weirdo.
Oh, yeah.
Not that you're a weirdo, but you know, that's how I feel about myself.
I can't go into any water that's deeper than my height, and I'm not even 5 foot, so
Oh,
basically not deep at all, really.
be scared of the bathtub.
Not that short. Or 11 and a half, that and a half is very important when you're short.
Almost to 5.
Just round it.
Yeah.
I'm 5 foot in my boots.
Okay, cool. You're good.
How old are you?
25.
18.
So you're pretty much opt out as far as
I'm
growing.
done. Yeah, I'm not growing anymore.
Most females quit growing by the time they're clean height wise, and with men it's usually around 22.
I haven't grown any since 5th grade.
Jeez.
Yeah, I used to be that
Yeah.
kid who was taller than everybody,
Yeah.
and then at middle school, I was the shortest one.
Yeah,
The
same thing with my
summer-
wife. She's
Yeah.
5'2". Actually, she says she's 5'2.5". She's gonna grab that half.
Exactly. See, 4'11" and a half.
The half wrappers, oh my gosh.
My daughter is, I don't know how tall she is. She's around 5'2", 5'3" also. But yeah, they all hit their max height, fifth, sixth grade.
Mhm.
Then my middle child in eighth grade, he grew 8 inches in 1 year.
Wow.
And I couldn't.
He's
get that.
6'3".
Thanks, sir. That's nuts.
So I call him the tall boy.
Yeah.
It's like and then my eldest, I call him the old son because he calls me old man. So he's turns 40 this year. Damn. Well, my daughter turned 26 already. So.
Maybe I could reach that 5 foot one day. A miracle happens, maybe.
Maybe.
Before y'all leave today, don't forget to sign in.
Maybe there is a God.
And people are showing up in Zoom. Can y'all hear me in Zoom?
Yes, sir, I can hear you.
Well, if you hear me, I'm not hearing you. Let me see.
Anybody need to sign in? You need to sign in.
Okay, talk again.
Sign in?
I'm not good at that.
Oh, okay. You sign in? Are you not part of the class?
Good.
Oh, okay. I have a lot of not students today. Sign in, Robert?
You're on Zoom. Go ahead and try and
Already
talk
done
to
it,
me.
thank you.
I'm trying to see if I
Everyone
can
good?
get the speakers to work.
Can you hear me?
What's going on? Who's the volume? No, they're turned up. Okay. We'll try a different set of speakers. Okay. Try again.
Hello?
There we go.
Okay.
Thank you. Oh, for some reason, I muted all my phone calls. This is a pain. My wife. We still have 4 minutes. So. You know what? My camera's not showing. There we go. See if the Reset works. Yes, the reset worked. However, someone posts with it.
Good afternoon, sir.
How you doing, Alejandro?
I hope you don't
apologize.
mind. I'm doing Zoom today.
That is perfectly fine.
Okay, thank you very much.
Apologize for not being in my Zoom this afternoon for my office hours. I had.
Oh, you saw me join?
Yeah. Well, I saw it after.
Yeah, I joined like twice. I was like, whoa, maybe I didn't join the right one. I joined this one and then I joined the office hours one. It's okay, it's fine. I was just gonna ask for permission to join the Zoom, but then after everything, I just went home and I was like, oh, okay. I'll join, and then it's easier to ask for forgiveness than to ask for permission, you know?
I live by
Well,
that.
I don't have any issues with it, so. There, that's better. Or is it not? Unfortunately, I was unable to get to grading. Yeah, my weekend has not been my own. And yesterday and today has not been my own as far as getting to the grading. So
That's good, sir. I want to stay in a good mood.
yeah, here we go.
Esteban, he's back.
Welcome back.
I like the new haircut.
Yeah.
He's fresh.
So did you get my email about why I didn't make it to class that day?
So,
I don't think he cares though. Okay. Right, sir? He's just happy. We're all happy you're alive.
all right. Did we go over this? I know in one class.
Barely.
Yeah. Barely. Did we cover cosecant and secant?
Yeah. Learn.
No, if we'd done it, it would have been tangent, cotangent. Well, let's get into it. It's gonna be looking at the graphs of tangent and cotangent and secant and cosecant. And the forms where you have A, the function of omega x plus b, where A is a stretch or a compression, a vertical, and omega changes the period, so it's either a compression or a stretch horizontally, and B is a shift vertically. And then in the next chapter, we add in phi.
Feet.
Phi.
P.
Phi.
Fee.
Phi. It's another Greek letter. So my fuzzy eraser.
Ah, it works. Great.
I like my fuzzy eraser. I left it in the classroom. I don't have it. Okay. So this is the graph of tangent, and they're limiting the domain of tangent for this graph. Realizing at pi over negative pi over 2, tangent does not exist. And same thing with tangent of pi over 2. So that's why they limited it. So these are the key points for a single period of tangent, which is from negative pi over 2 to pi over 2, because the period of tangent is 1 pi. And this is what the graph of tangent looks like. It just repeats over and over and over. Tangent, if you recall, is an odd function. That means it's symmetric with respect to the origin. If you take a point on the graph and change the signs of both the x and the y, you get its mirror image. So like this point over here, which would be 5 pi over 4, 5 pi over 4 comma 1, is going to have a matching point over here at negative 5 pi over 4, negative 1. You change the signs, it will have a matching point because they are symmetric across the origin. So that's how odd functions work, and that's how it works with this one. So if I go to the point over here, it's gonna be over here. And so that's what we have there when we're dealing with odd functions. And since tangent is an odd function, that's how it works. The only portion of this graph where it goes back to the same part of the graph is in the first period, or the initial period, primary period. I don't remember. I don't know what they call it. But this is a primary period from negative pi over 2 to pi over 2. At the odd multiples of pi over 2, you end up having a vertical asymptote, because at those values, tangent does not exist because you're dividing by 0. So here are the properties of the tangent function. The domain is all real numbers except odd multiples of pi over 2. The range consists of all real numbers. If you look at this, each portion of the graph goes down to negative infinity up to positive infinity. So the y values cover all of the real numbers. It's an odd function, which I already discussed. The symmetry is with respect to the origin. The tangent is periodic. It has a period of pi. The x-intercepts are the multiples, integer multiples of pi. -2, -1, 0, 2, 3, 4, 5. So that's where it crosses the x-axis. So, oh, whoops, wrong way. So yeah, you notice here it hits at multiples of pi is where it crosses the x-axis. And the vertical asymptotes, like I said, these are odd multiples of odd integer multiples of pi over 2. Okay. Now the cotangent, tangent and cotangent are inverses of each, are reciprocals of each other. They're not inverses, but they're reciprocals of each other. So where the x-intercepts are for tangent, which is where tangent equals 0, cotangent doesn't exist. And where tangent doesn't exist, the cotangent equals 0. So these will switch. The intercepts for cotangent will be the vertical asymptotes, and the vertical asymptotes for tangent will be the x-intercepts for tangent. And we'll get to that in another slide. So here, I don't know why they just didn't show the same thing they showed with tangent. They didn't show that portion of the graph. Here they go from pi over 6 to 5 pi over 6 in the x values. So the period is between 0 and pi. Where tangent is from negative pi over 2 to pi over 2, it's been shifted a half a pi this way. And instead of coming from negative infinity and going up to positive infinity, it comes down from positive infinity and goes to negative infinity. It has a similar shape. It's just been flip-flopped. And again, this one is odd as well. This point has a mirror image over here. Negative pi over 4, -1. Oh, that's going to be here. Sorry. And this one would be over here. So that shows that fun stuff. Okay. And they didn't go through and talk about the properties of COTAN. I don't know why.
Is the domain integers of pi over 2 except for the
The
even?
domain is all real numbers except for
The even.
or
Multiples.
the multiples of pi over 2, the multiples of pi.
Okay,
That's for
Integer
cotangent?
right?
for cotangent.
Okay, because the opposite of tangent, which is the odd multiples of pi over 2.
No.
I mean, it's except for the odd multiples of pi over 2.
All right, if we look back here, the intercepts are what are not in cotangent.
Yeah, because it doesn't exist there.
It doesn't exist here, which are the integer multiples of pi. So that means for the domain here, it's going to be all real numbers except for multiples of pi, integer multiples of pi.
Even or odd.
Huh?
Even or odd.
Right.
Right.
So that's why we just say integer multiples.
Okay.
Yeah, and yeah, here, it says it here.
Oh, yeah.
This is our domain, except X is not an integer multiple of pi, and Y is all real numbers. I don't like using the graph to graph these things. I like using points. And then graph the points. So we have 3/2 tangent of X plus 1/2. So this is what our function is. So looking at those key values for tangent at negative pi over 4 and 0 and pi over 4, because at pi over 2 it doesn't exist, and a negative pi over 2 and positive pi over 2 it doesn't exist. So the function, the graph looks like that. So at negative pi over 4, what is tangent? Isn't that negative?
Square root of 2 over 2 over square root of 2 over 2.
Which is,
2.
try again.
Who else? I gotta work it out. I should just know it.
All right, look at, no, just look a second. You're saying the square root of 2 over 2 divided by the square root of 2 over 2. So if I look at my numerator and my denominator, what do you notice?
They're the same.
Would it just be 1?
Yeah. So, but at negative pi over 4, cotangent is what?
1.
Try again. Yeah, -1. Because what quadrant are we in? Negative pi over 4, we're in the 4th quadrant. And tangent and cotangent are negative here. The only trig function that's positive here is cosine. And cosecant. No, and secant, sorry. So so at 0, it's going to be 0. Right? Because you end up dividing by 0 because it's 1 over 0. I know 0 over 1, sorry. Sine over y over x. And at pi over 4, well, that's going to be a positive because these are mirror images across the origin. So the next thing we do, we're going to multiply each of the y values by 3/2. So this is going to be negative pi over 4, comma, negative 3/2. And this stays 0, 0, because 0, anything times 0 is still 0. And then multiplying 1 by 3/2, we get pi over 4, 3/2. So that's what happens with the amplitude. We multiply the y values by the a value.
There's only 3 key points in tangent.
Well, yeah, because because now it takes a dive down
Okay.
and never reaches negative pi over 2. So it keeps going negative, more and more negative, the closer and closer x gets to negative 1/2.
Then we multiply by 1/2.
This, what are we doing here?
That's the amplitude.
No, this is the amplitude.
Oh,
That's A.
yeah.
A equals
Oh, that's our period, my bad.
3/2. No,
No, that's not our period. 1/2. 1/2.
we're at this gives us a y value. We're adding to that y value.
Okay.
Okay.
If it happens to x, it's going to be inside here.
Yeah.
Ah.
Giving us the angry dad voices.
Oh, I gotta tell my daughter that. You sounded just like her. Okay, so now I'm gonna add 1/2 to each of these y values, including the 0 here. Negative 3/2 plus 1/2.
It's 1/2.
No, negative 3/2 plus 1/2. Negative
Oh, I see.
3/2 plus 1/2 equals a negative 3 plus 1 divided by 2. Which is negative 1. Because you get a negative 2 over 2, right? So this becomes a negative pi over 4, negative 1. So this point came back up to it.
Oh, yeah, I did.
But what happens to the point 0, 0?
It goes
Yeah.
up 1/2.
It went to 0, 1/2. Because 0 plus 1/2 is 1/2. And now I had 1/2 to 3/2.
Two.
Gives you 4/2, which is, 2. So this goes up to pi over 4, 2. So that's how I graph this. And because I did not change my period, omega here was 1. So that means I didn't change my period. So it's still going to be between negative pi over 2 and pi over 2. And that's where my vertical asymptotes are. And I graph these 3 points, negative pi over 4, negative 1, 0, 1/2. That's 1, so that's going to be 1/2. So 0, 1/2, and pi over 4, 2. Up to here. So now it comes like this. And then if you're asked this on a test, you would mirror it here and you would mirror it here. So it'd go up to pi and this point And this point would be at 3 pi over 4. No, this point would be more than that. It'd be another pi unit. So that'd be 5 pi over 4. And this one would come up to pi over 3 pi. And this would, this one would come over to pi, I1/2. You would add pi to each of the x values of these 3 points to get the next ones over here. You'd subtract pi from each of these points to get these down here. Since the period is pi, then these points get repeated every pi unit. So pi, add pi brings you here, add another pi, and that's how you would do that. To repeat it. So I'm not too sure how they're going to do it. They may do it with the graph. They may do it with the way I did it. So I'm going to erase what I have up here. And we'll see how they do it. Using the graph is because I draw everything on top of each other, it's awfully confusing because you don't know which graph I'm drawing. Sometimes I don't either. So it shows the steps in using the transformations, which means they're going to use the graph. So the first thing they did, they multiplied each of these y values by 3 halves. So the point that had been up here is now down here. The point that had been down here is now up here. And same thing as you go up and go down. So that was the first change in the points.
It's changing the Y.
What?
Changing the Y.
You change the y. The x values don't change at all in this problem because omega is 1. And there's no phase shift, which we'll get to in the next chapter. Okay. Now, we do that adding 1/2. And I wish they had continued, if they had put this picture on the next slide as well. So I'm just going to bounce back and forth. I hope it doesn't bother you too much. All right. So adding 1/2 to this, adding 1/2 to the y values. So this went up to -1, and this one went up to 1/2, and this one went up to 2. So it's just shifting the whole thing up 1/2 unit. I just went the wrong way. And there we have it. Notice they're not telling us what these values are, because
They don't exist.
I wouldn't even want to try. Okay. That's a calculated part.
Is that where you go into the TI and then you go down to the points? So you get it right there and then it
Well,
gives you
no,
that big old
in the
decimal?
graphing calculator, you say x-intercepts,
X-intercepts, yeah.
and it'll tell you where they are.
You follow it all the way down.
Okay. So now, when you have a graph in this form, the domain is, oh, they don't have omega thrown in. Oh, this way. Okay, because omega is 1. It's all real numbers x, such that x is not k times, and I write it differently than they do. I write it as pi over 2k. where k is an odd integer. You'll come to notice in mathematics k, I, and n usually denote integer numbers, and j as well. I and j is primarily used with summation.
They're not constants?
Huh?
They're not constants? Not used as constants? Thought N was.
Well, they're used in this context. And they'll always say, depending upon what's going on in the summation series. If it's a summation series, you understand that I and j are integer numbers. Same with n. N is almost always an integer number. So if it's ambiguous, then they'll state that it is an integer number. Or in this case, it's an odd integer. Okay. And the range is always going to be all real numbers. There's once the range or the domain is all real numbers, something serious has to happen for it to change. Okay. So for every tangent function, you can probably bet on that its range will be all real numbers. And you can either say the set of all real numbers, or you could say it's the interval negative infinity to infinity, or you could say all y such that y is a member of the real numbers. This here is saying the same thing as y is a real number. This is a set notation. It means a member of belongs to is an element of. It kind of looks like an E, but it's more of a half a circle with another line through in the middle. And it originally was from element of. So. And then the stylized R means we're talking about the real numbers. And depending upon the textbook, that symbol could be a scripted R, it could be a boldface R. I just learned to write it this way. So. Now cotangent. Notice they're not adding or subtracting anything. So it's just this function here. But we have omega. So now the period is going to change. Omega equals 2. Nope, because the period here is not 2 pi. Okay. What's the period? Period for cotangent and tangent is the same thing. Pi. So the period you get by doing pi over 2. I mean pi over omega. Yeah. And in this case, it's going to be pi over 2.
Okay, so that's our formula for tangent.
No. For period.
For period. Oh, okay, yeah.
Yeah.
So now it's just instead of 2 pi, it's pi.
Right.
Okay.
The reason we've been using 2 pi is because 2 pi is the period size for sine and cosine.
Right. Yeah.
If omega is 1, then 1 pi over 2 divided by, 2 pi divided by 1 is just 2 pi.
Mm-hmm.
Here, if it was 1, then pi over 1 is just 1. So it's the period remaining the same. But here, I'm doing a compression. Okay. So instead of going from that primary period, instead of going from 0 to pi, now it goes from 0 to pi halves. So So now it's going to go from 0 to pi over 2. And again, I need to divide this into 4 regions. So halfway is pi over 4. And halfway between 0 and pi over 4 is pi over 8. And the other halfway in here is going to be 3 pi over 8. So we've condensed this here. We've condensed it down this way. So we've scrunched it down into here. The scales are not the same. So that changes our x values. Yes.
I know how you got pi over 4 and then how you got pi over 8. How I would get that 3 pi over 8, what I would do is I would
What's halfway between?
yeah, I get the average. Is that how I do it?
Yeah.
Okay. I was just wondering if that was correct. Just get the average of pi over 4.
Or you do pi over 4 plus pi over 8.
Okay.
Yeah, it's because now each of these is 1/8.
Oh.
Pi.
Okay. So I can do that too.
That's how the textbook does it.
Oh, okay. Yeah. No, I was because when I was on the test, what I would do is I would get the average of it basically.
That is fine.
Okay.
You end up getting the exact same number. It's a little extra work, but that's okay.
Sir.
Yeah.
Could you work out the bottom equation, please?
The what?
The pi over 4 and pi over.
All right, I need my denominators to be the same. So 1/4 is 2/8.
Okay.
So that's going to be 2 pi over 8 plus pi over 8, which is 2 pi plus pi over 8.
Yep.
When you're adding, you keep the same, you keep the denominator and all the action happens in the numerator,
Yes.
whether you're adding or subtracting. So 2 pi plus pi is 3 pi. So you get 3 pi over 8.
Sir.
So now my key points were at pi over 4, pi, and 3 pi over 4. So this was at pi over 4 was 1, pi over 2 is 0, and 3 pi over 4 is -1, because it comes down like this. Okay. So my y, I haven't done anything to change my y values yet. All I did was change what my x values are. So instead of pi over 4, it is now pi over 8, 1. The pi over 2 is now pi over 4. So now it's pi over 2, 0. And instead of being 3 pi over 4, it's now 3 pi over 8. -1. And at pi over 2, we have, just like here we have a vertical asymptote, here we have a vertical asymptote, and there's still a vertical asymptote at 0.
Okay. So pi over 2 should be pi over 4.
This pi over 2 became pi over 4.
That's it.
Yeah, that's, oh.
Good.
Now we multiply by whatever A is. And A affects the Y values. So we do A times each of these Y values. So this becomes pi over 8, 4, no, 3. Oh, where I got 4 from? And then 3 times 0 is still 0. So it does not affect our x-intercepts. And then 3 pi over 8, instead of going to -1, now it goes down to -3. And our asymptotes remain the same. So we have a horizontal compression and a vertical stretch. So this graph, here I have an asymptote. And over here at pi over 2, I have an asymptote. And here at pi over 4, it's at 0. And at pi over 8, it's at 1. I mean at 3. And at 3 pi over 8, it's down here at -3. And so the graph goes like this. And as x approaches pi over 2, the graph of it gets closer and closer to the line x equals pi over 2.
And we have no vertical shifts because there's no B.
Right.
Okay.
Or b is 0.
Okay.
We're always adding 0, so the vertical shift is 0. Which means we don't move.
Mm.
Okay. So again, they did it using the graphs. This is how I used to do it. But doing the graphs, what did they do first? Oh, first they changed the period. No, they changed the stretch. They multiplied by the 3 first. Well, we could have done that. And so these would have been, this would have been it would have been the pi over 4, 3, pi over 2, 0, and then the pi over 4, -3. And then we would change the x values to get to here. But yeah, whichever method you choose to do, you should wind up in the same place. Yeah, I hit the wrong button last time and I answered the phone. Okay. And so they did the vertical stretch first, and then they did the compression. Replace x with 2x. It's a horizontal compression by a factor of 1/2. Multiplying each of the x values by 1/2 gives us the same result. 1/2 times 1/4 pi is pi over 8. 1/4 times pi over 2 is pi over 4. I mean, yeah. And pi over 4. And then 3 pi over 4 times 1/2 is 3 pi over 8. So yeah, gives us the same place. And then you add 1/2 a pi to get over to here, and add 1/2 a pi here to get over here, and add 1/2 a pi to get over here. And then you add 1/2 a pi again, or you subtract 1/2 a pi to get on to go the other direction. And in that case, you're just changing the x values, or the y values will remain the same. Okay. The domain. Okay. So the domain had been every pi for cotangent for cotangent x. The period is pi, so that's going to be the multiples of pi, because it starts at 0 and goes to pi and to 2 pi and negative pi and negative 2 pi. But now I cut that in half And so instead of being the multiples of pi, now it's the multiples of pi halves, which includes pi and 2 pi and 3 pi, but also the half names, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, on up, and in the negative direction as well. And the range again is all real numbers. Okay, questions? I'm pointing it over here like that, but it's actually over there. But anyway, this is cosecant. Cosecant is the reciprocal of sine. Sine and cosecant, cosine and secant.
Tangent code.
Right. The reciprocal, like for sine, between negative pi over 2 and pi over 2, all the values for sine will be a fraction between 0 and 1, between -1 and 1. But when you do the reciprocal of those numbers, they all become either bigger than 1 or smaller than -1. The reciprocal of -1/2 is -2, where the reciprocal of +1/2 is +2. Flip the fraction.
Yeah, sorry, I just didn't know to put it negative since it's a reciprocal.
No, reciprocal has nothing to do with the sign. It has to do where the numbers are in the fraction.
Gotcha.
So that means for cosine does not exist between between -1 and +1 in the range. The range does not have fractions.
Cosecant, sir?
Fractions between -1 and 1. Cosecant. Well, secant 2. So that's what this is saying, that the absolute value of y, because y can be a negative number and y can be a positive number, will not be, y will have to be greater than or equal to +1, the absolute value. And that covers both ends. That covers it, y greater than or equal to 1 or y less than equal to -1.
Yeah, because of an absolute value.
Because, yeah, absolute value means you're going to turn all of these positive, so they have to be bigger than 1. If I do absolute value here, I have to do absolute value here, and that'll change the direction of my sign. So this statement here covers both of these situations. Yeah.
Sir, is this symmetric with respect to the origin?
Yeah, it's an odd function.
Okay.
Sine is an odd function, which means its reciprocal function is going to be an odd function.
Is that a rule that the reciprocal?
That
function
is, you can bet your life on it.
Okay, so then there is like an even one, the reciprocal will also be with
Even.
respect to the,
Y-axis.
okay, which will also be.
Cosine and secant are even functions, which means they're reciprocal with respect to the y-axis. So we move this, we just shift this pi, half a pi unit, and you'll get secant and tangent and cosine. secant and cosecant look the same, except they've been shifted. Just like sine and cosine look the same, they've just been shifted, horizontally shifted. It's a phase shift. Well, yeah, with the trig functions, a horizontal shift is called a phase shift. Well, it comes from electronics. And here's the graph of secant. It the same kind of deal. The range is the same. The domain is a little different because now it's odd multiples of pi over 2 are not included in the graph.
Like cosine.
You mean cosecant? Cosecant,
Oh, yeah,
It's-
yeah.
it's integer multiples of pi. But here we say odd multiples of pi over 2 because instead of integer multiples, because if I multiply pi over 2 by 2, I get pi. Well, pi is obviously in the domain because we get -1. So, whoops. So it's from half a pi, -half a pi, to pi over 2. And actually, the first a period here for secant and cosecant is 2 pi, just like the period for sine and cosine is 2 pi. So inside here, notice we have a asymptote inside a period. Just like with cosecant. Well, within cosecant, we don't have. Yeah, we do. It's because it's right here. You just can't see it.
The vertical asymptote?
The vertical asymptote is on the y-axis in this case.
So it goes in between the period.
Yeah.
Whereas on the other graph, it didn't go in between the period, the vertical asymptote is going in line with the period.
For tangent, cotangent, right?
Oh, the other one, sir, that you just showed, was right here. Vertical asymptotes.
This vertical asymptote is inside this period.
Gotcha. Okay. Okay, that's the same.
Because the period is 2 pi. This is only 1 pi. So I have to do another pi for the whole period.
Gotcha.
Okay, and they're funny looking graphs. I'm gonna see how they do it. And I bet they do it using the graph. Yeah. So. Yeah. So the function they dealt with here, they dealt with the stretch first. So this point here and this point here went down by a factor of 2. I multiplied the -1 by 2 to get -2. I multiplied the -1 by 2 and got -2. Here I multiplied it by 2, the 1 by 2, and it went up to 2. So And it stretched it up so now they're gonna be a little narrower because it goes down faster. Actually, it goes down slower. Yeah. But, or up. No, it goes up faster, it goes down faster. And then the next one is a horizontal, I mean, a vertical shift.
-1.
Because, yeah, so instead of going through 2, now it's gonna go through 1. And instead of through -2, it's gonna go through -3. So all these points got shifted down 1 unit. And notice they quit drawing the sign. And it's just really, with secant and cosecant, is just really tracking where these points are. What happens to these points? And you know where and tracking what happens to those vertical asymptotes. There's no phase shift, right? Oh, there is a
Yeah.
phase shift, isn't there? And that's what, no, there is no phase shift. Because it's just a 2
Oh, yeah.
cosecant x. Omega is 1, so there's not going to be a phase shift.
Once again, they're just changing the y.
Right, just in this case, they're only changing the y. They multiply it by 2 and then they subtract 1. So that's what happens with the a and b. The a, you're multiplying the y by a, and the b, you're adding to the y. So it's going to be a times the y value plus b. You do that all in one step. -1 times, what was it? -1 times 2 minus 1. Put you right here. And 2 times 1 minus 1 puts you right here. And this is just going to be repeated. So all these high points down here are going to be the same. And all the low points up here are going to be the same. They're just going to be a pi apart.
So our key points are -2 pi and -1 and pi over 2 and 1 and 3 pi over 2 and -.
Yeah, and just realize you have a distorted parabola going down and one going up, one going down, and one going up.
Those are the key points for cosine.
And secant, but with secant, again, it shifted a half a pi. So this would be here. No, it'd be on this one. This would be here, and this one would be here, and this would be here, and this would be shifted to here, and this would be shifted to here, and this would be shifted to here on down the line. Everything is shifted 1/2 pi.
We haven't done a secant problem yet, right?
Now, the domain didn't change because we didn't do any, omega was 1. And so it's all x, all real numbers x, such that x is not k pi or k is an integer. Any integer, including 0. And then the range, yeah, the range significantly changed because on the negative side, the highest value is -3, so it's from -infinity up to -3, or y is less than or equal to -3. And on the high side, the lowest value is 1, so y has to be greater than or equal to 1. Or the interval 1 to infinity being closed at 1 and -3. So it's closed at -3 because it can equal, and this is closed at 1 because it can equal. Didn't we just do this?
Yeah. I think this is repeating itself.
No, what happened was, why did you stop? Uh-oh. I freaked it out and I closed. I have to find it. Oh, we should put this on desktop. Oh, there it is. Where is it? Close that. Section, here, we go, section 6.6. Phase shift. Phase shift is always fun.
Yeah, it looks like you have a spry smile on your face, sir.
Yeah, people believe that. Okay. So phase shift. We're going to graph a sinusoidal functions of the form y equals sine of omega x minus phi. Plus b. This is another Greek letter. Mathematicians love using Greek letters, especially for angles. And it is pronounced phi. Some people pronounce it phi because it is spelled phi or sometimes with a y. I don't know. So, phi. And then build sinusoidal models from data. This is more using the graphing calculator. So you will not see one.
Not much, my friends.
You will see them
This one too.
not
This
on
from the
my
beginning,
exam.
when this one's like kind of more recent.
But you will be asked to graph a sinusoidal function or two.
Oh, I don't have that.
For the gra-
This is. It's just not meant to be said.
I'm gonna test here in a minute.
Sir, no.
The other day I was having similar problems in a class, except it was with Zoom, not with PowerPoint.
Oh, that's worse.
Yeah, my screen would freeze. So it got to the point in one class, it happened 3 times in one class, 4 times in one class. It got to the point where I had about 4 or 5 people yelling at me saying, "Sorry, your screen froze." So it was an easy fix. It was just being able to go. Okay. So for the graph, we have several things going on here now. We have the amplitude change. Okay, the amplitude is still A. We have a vertical shift of B. So we're multiplying by whatever sine of whatever the angle is, it's gonna multiply that Y value by A and then add B to it. So the change in the vertical is a simple thing. It's multiplying by A and then adding B. The trick becomes, what's the Y do we get? Because we're changing our X value. We're changing it by multiplying by omega and then subtracting phi. So we have a phase shift, which is phi over omega. We have a period, which is 2 pi over omega. And if phi is less than 0, then we have a shift to the left. And if it to the right, if phi is greater than 0. So if phi is less than 0, then that means we're going to be subtracting a negative number, which means it's plus a number in here, plus a positive number. And if phi is positive, then it's going to be subtracting a positive number. Remember with x's, that sign in between, the x will be the opposite sign? Yes. Okay. So that's what we deal with there. Okay. So phi over omega is how far we're moving to the left or right from the initial angle. Well, after we change it, after we do the phase shift, actually, I mean the period shift. Well, we do the phase shift and then we do the period, change of period. So find the amplitude, period, and phase shift of this function. Well, the amplitude is easy. What is it? 3. What's the period?
2 pi over omega, and omega is 2. Oh no, omega over or pi over omega.
Nope.
Pi over-
Because we're dealing with sine.
Oh, it's that side. I didn't see that. Okay. So then 2 pi over 2
2 pi over 2, which is
pi
pi. So the new period
0.
is pi. So t equals pi. And the phase shift,
More than 0.
the phase shift is phi over omega. What's phi? So with these types of problems, it's a good idea to identify the parts. All right. A is 3. Omega is 2. And phi is what? Pi. If it was plus pi, then it would be a negative pi.
So then so then phi and the period are the same.
No,
Because then we say that 2 pi.
well, in this case, yeah,
and
but
this
it's
case.
not always
Okay.
the same.
Okay.
Just this is a special case where it winds up being the same. And you said that the period was pi? Because that's 2 pi divided by 2.
You can't say 2.
And so what is
So you have, a negative pi and you can switch it out and you subtract it.
the formula, what's in here is omega x minus phi.
Okay,
So if phi is negative, then it's going to be minus a negative pi, which would be plus pi. But since we're subtracting pi, that means phi is pi. Yeah, it's kind of
Okay.
weird. It's kind of weird how math is.
I wanted to add the negative, but. No.
Then it would have been for pi to for phi to be negative, then this would have been 2 pi plus pi. I mean 2x plus pi. Because for pi for phi to be negative pi, it would have been minus the negative pi. Because
got
you're
it.
subtracting whatever phi is.
Okay, thank you.
These questions need to be asked. So the phase shift, there's not a symbol for phase shift. They use the word phase shift. So the phase shift is what? P divided by omega. So P over omega is pi over 2. P over omega,
Oh, man.
not the period. So it's 1/2. So the graph is being shifted 1/2 unit to the right.
So our phase shift is phi over omega.
No, pi over omega. Oh, phi
Yeah,
over
yeah,
omega, yes, which is pi over 2.
Okay.
And that's what they're asking for. Is
Yeah.
the amplitude. They're asking for this, this, and this. But we need these two things to find these two things. What are they saying here? Use the 4-step process used to graph sinusoidal functions in the form y equals. Okay, so we use the same
What we've been doing.
deal, yeah. Please notice what they did. They divided, this here, they divided 2 out of both of these to get this here. So if you use the determinant property, you get that back. Well, that tells us this is omega and this is phi, which is what we got. Right? Omega and phi. No, the phase shift. I'm sorry. The phase shift.
So why is there negative?
What? Why is what negative?
Does the minus sign make it negative? The
No.
phase shift? No, okay.
Because you're subtracting whatever the phase shift is. If the phase shift is negative, then it would have been plus.
Mhm. Gotcha, sir.
Oh, I just explained myself again.
Yeah, so you're looking at me like I'm crazy.
Well, that's not far from the truth, is it?
Oh my gosh. Oh my
Okay,
gosh.
Okay.
Yeah.
Yeah, you left yourself wide open for that one. So the graph is a sine curve with an amplitude of 3, a period of pi, and a phase shift of pi over 2, or 1/2 pi, or pi halves. I say it any one of those 3 ways. Now. Yeah. So one cycle begins at pi over 2. I'm gonna do it their way. I just have given up and decided to use their way. So because for sine, the first cycle begins at 0, but we're adding pi over 2. So that means it's going to start at pi over 2. And the phase, since the period is now just pi, so I'm going to have to add pi over 2 to pi. So it goes from, so the original thing here goes from 0 to pi, but I'm shifting it 1/2 pi. So it now, instead of going from 0 to pi, now it goes from 0 to 3 pi over 2. Now comes the fun part, is finding out what those are.
Yep.
So I have pi over 2, and I have 3 pi over 2. What is halfway between? Well, that's not taking half of this. That's adding these two together and taking half.
So.
Or is it subtracting?
So it's two.
Wait, no, it's right, it isn't.
2. 4 pi over 2.
Yeah, with you there.
4 pi over 2, and then you divide by 2. You take the 2 out, so you're left with 2 pi. Oh, no, that's not.
No, it's gonna be pi.
Pi.
Well, let's see
Close.
what they do. Okay,
2 pi.
so,
2 pi.
no, says 2 pi is too big. Because it's halfway between these two numbers.
So you add them.
So you take their average and that gives you halfway. So half a pi plus 3 pi over 2 is 4 pi over 2, which is 2 pi, and half of that is pi.
Pi.
Yeah.
Great.
But what they're saying here is that because it's this distance here is 1 pi, each section is going to be 1/4 of a pi. So I'm going to add 1/4 pi to pi over 2, which gives me 3/4 pi. And I add another 1/4, which is pi.
Yes.
And then I add another 1/4, which is 5 pi over 4. Which is how they do it. So they add 1/4 of a pi each time to change where the shift from 0 to pi, where does that shift to? Well, it shifted, each of those x values shifted up 1/4 pi. So now my 5 points are pi over 2, 0, and this is for sine. And then it's going to be, what is it, 3/4 pi? It's going to be at 1. And then pi is going to be at 0. And what is it? 5/5 pi? Yeah, that's what they got. 5/5 pi. 5/4 pi is going to be at -1, and then at 3/2 pi, it's back to 0. And I know for on Zoom, I think I went off the screen. Yes. So where's my handy dandy little controller? Let me kind of zoom in a little bit there, so you can see what I'm writing. Okay. And so these are now my key points, but I have not applied A yet. A, or is there a B value on this one? Okay, so the A value, I'm just multiplying each of the Y values by what? Are you ready? 3. A is 3, so I multiply each one by 3. So the Y values, because A affects the Y values. So now we have pi over 2, 0, pi over 3 pi over 4, 3, and pi 0. And so go back to this. So if I go to, I'm not practically on top. So we have pi over 2, and it's at 0. We have, what's the halfway point?
Pi.
Pi. And it's at 0. And at 5 pi over
No,
2.
3 pi over 2.
Oh, 3 pi over 2. It's at 0. And halfway between, it's at positive. So it would go up to 3 up here. And down here, it would go down to -3. So halfway between here, it's down to -3. And so there we have it. And then you plug in your appropriate values and you repeat, going at least once going up and once going down. And so, yeah, so they got this, the key values there. And then they graph those points. And then I think they extended it. Yeah. So they went 1 pi unit down, and they went a pi unit up as well. So they did half a period in both directions. And we'd be done, I think. The only difference would be the only additional thing would be if there is a vertical shift, either up or down. So that would be the B value, but the B, there's nothing being added, so we're adding 0, so there's no shift up or down. Oh, here they're using the transformations of the graph. I just prefer, I use the points because I see it as less messy than trying to do it with the graph, but and they dealt with the amplitude first, saying it goes up to 3 and down to -3. And then they did the they did the compression. So half a pi became a fourth of pi, pi became a half pi, 3/4 pi became 3/4 pi, and 2 pi became pi. Because we multiplied each one of those by 1/2. 1 over omega. And then we shifted everything. We shifted all the x values 1/2 pi to the right. So 0, 0 got shifted over here to 1/2. 3/4, 3 got shifted over here to 3. Pi force got shifted to 3 force pi. And pi over 2 got shifted over to pi. And then this got shifted down, shifted up, and this got shifted 1/2 pi. So that's how they do those. It's still the same graph. The end result is the same graph. So they look at what happens. They look at what happens with the period, and then they do the phase shift. All right, this one gets a little more complicated because we have an A value and a B value. And we usually wait and do the B value at the very end. So for cosine, it starts at
0, 1.
0, 1, and then pi over 2, 0. And then at pi, it's -1. And then at 3/2 pi, it's back to 0 again. And then at 2 pi, we climb back up to 1. So the graph here kind of goes like this. Now, the phase shift, and well, we can do the vertical stretch first and get that out of the way. So I'm multiplying each of these y values by 4. That means the maximum it approaches is 4, and the minimum it approaches is -4. So this would be 0, 4 pi half 0, and then pi -4, and then 3/2 0, because 0 times anything stays 0, and then 2 pi is back to 4. And now everything that happens in here changes our x values. Well, we could change our y values now with the -1 if you wanted to.
Just subtract everything, or subtract the y.
Subtract the y values by 1, because that does not affect our x values. So this is 0, 3. And this is pi over 2, -1. This, in effect, that -1 moves our x-axis down 1 unit. And then pi -5, and then 3 pi over 2, -1, and then 2 pi 3. So we change the y values by multiplying by 4 and subtracting 1. Now we're going to change the x values. First of all, I'm going to rewrite this as 2 times x plus 3/2 pi.
Could you subtract or divide it by 2?
because I divided 2 out of both of those.
Yeah.
So this is omega. And this is our phase shift. Our phase shift is 3/2 pi. Our omega is 2, so our period is pi. Right?
Yes, because
2
2
pi
pi over
divided by 2, yeah, okay. So now it's from 0 to pi. And so we find those, which is
Pi over
just
2.
a standard pi over 2. So each one is 1/4 pi. Each area, each section here is 1/4 pi long.
3 pi over 8.
Uh-uh.
Uh,
3 pi over 4. Yeah, it's 1/4, 1/2, 3/4, 1. And now we add 3/2 to each of those numbers. So 0 plus 3/2 pi and pi over 4 plus 3/2 pi. And then pi halves plus 3/4 pi. Oh, no, it's 3/2 pi, sorry. And then we have 3 pi over 4 plus 3 pi over 4, over 2, sorry. And then pi plus 3 pi over 2. So each of our x values are going to become these numbers. So 0 just becomes 3 pi over 2. So the whole thing got shifted. It got shifted 1.5 pi's. So 1/4 plus 3/2. Well, the 3/2 can be written as 6/4 pi.
Yeah, I was about to say the common denominator.
Right. And so that becomes 7/4. So this is 7/4 pi negative 1. Right? Because now we changed our y values already. And now we're changing our x values
9 pi
twice.
over. Next one.
So, well, the next
Oh,
one
no.
is 1/2 pi plus 3/2 pi.
Yeah.
1/2 pi, 1/2 plus 3/2 is 4/2, which is 2. So that's just 2 pi.
Yeah, no, my bad. I did 3 pi over 4 plus 3 pi over 2, which would be 9 pi over 4.
That's -5. And then get the same denominator, so that's going to be 6 pi over 4. So 6 pi over 4 and 3 pi over 4 make for 9 pi over 4. So that's just 1/4 pi larger than 2 pi, comma, this one, right? -1. And then the 2 pi,
Which is fine.
well, it's pi
Oh, yeah.
plus
2 pi.
3/2 pi. Well, no, this is going to be 2 over 2 pi. Because 2 over 2 is 1, so that's still pi. And so that's going to be 5 pi over 2.
Can we just clarify the pi over 2 here? And then the 7, clarify that a little bit around there.
Which,
You've got the second point. You've got 7 pi. Where'd you get that from?
the 7 pi over 4, that's 1/4 pi plus 3/2 pi.
So basically then you're adding,
6/4 pi to 1/4 pi. I multiply numerator denominator by 2.
so then we're adding the 3 pi over 2 plus the 1/4.
Right.
Got it. Thank you.
You're adding 3/2 to each of these. And so you graph those points.
So the phase shift really is just adding a little extra step to the period.
Well, it's not changing the period, it's just
Yeah, adding to,
where
adding or subtracting.
where the period now starts, instead of starting at 0, now it starts at 3/2 pi. It's still just 1 whole pi from here to here.
Mhm.
So they did the same thing I did right here. Only I didn't bring the 4 down. And then erase all this up here. And this over here. And I'll leave it here. So, yeah, and I didn't go through and identify each one of these. Oh, you know what? Uh-oh. We were supposed to subtract because now phi is negative, so that would have been a negative 3 pi over 2. I did not pay attention to that. Because now this is a minus a negative 3 pi. So phi is a negative 3 pi. So phi over omega is negative 3/2 pi. So instead of being shifted in a positive direction, it was shifted in a negative direction. Yeah. So instead of starting at 3/2 pi, it would start at a negative 3/2 pi. Because we had the 0, we had the pi over 4, we had the pi over 2, and the 3 pi over 4, and the pi. So we're going to subtract it instead of add it. But I'm just going to add half a pi. If I add 1/4 pi each time, I'll get the right number. So these were wrong. So if I add a fourth to this, so that's going to be a negative 5/4, negative 1, and adding another 1/4 of a pi here gives me 6 pi over 4. No, gives me a negative 4 over 4. So that's going to be negative pi. And that is going to be a negative 5. And then adding another 1/4 pi gives me a negative 7, no, a negative 3/4 pi, and that's going to be back up to a negative 1. And then adding another 1/4 of a pi. Wait a second. Is that right? Oh yeah, that's going to give me a negative 1/2 pi. And that'll be back up to 3. each of these periods is a fourth of a pi long, each of these intervals. And so I add a fourth of a pi to that, add a fourth to get this new number, and then add a fourth of a pi. And because we're adding a positive to a negative, we're subtracting the numbers. And since the negative number is larger, or it's more negative, then our answers are going to be negative. I'm so not happy with this program. I don't know why it's doing that.
Funky day, sir.
My week has not been fun, and it's only Tuesday. Well, as soon as we're done with this, we're done for the day, so. Oh, too far. Talking about inverse functions. Yeah, we get to inverse functions next. Which problem? Not that one. This. Okay. So it begins at a negative half. No, ends at negative half pi and begins at negative pi over negative 3 halves pi. Okay, yeah, so yeah. And since the period is divided into 4 equal parts and the period is 1 pi long, so each section is 1/4 pi. So then now they're just going to add 1/4 to each of those numbers. So we add 1/4 to the first one and get the second x value, and then add a fourth of a pi and get the third number, and add a fourth of a pi to get the fourth number, and then add a fourth of pi to get the last number, which we already knew what it was. And then they change. Oh, first they found the x values, and then they go through and change the y values. Multiplying by 4 gave us those numbers, and then subtracting 1 changes those numbers again. So they just graphed it, but they didn't -1 to each the y values yet. And so the next slide should be them having it slip downwards, in which it did. And so, and that was doing the graphs, but I would graph these 5 points and then extended a half a pi that way and half a pi up this way, because half a pi is half the period. Yeah, it comes up to -1/2 pi. And so another half period would be to here. Actually, they went up, I'd go a full pi. Just to show the y-intercept. Okay. And this we're not going to do, although you do have homeworks on this. So if you get to the end of the homework and you have issues with doing this particular stuff, which somebody in one of my 2 classes already has, email me and we'll do it in class. or we'll talk about it through email, or we'll create a Zoom and discuss it. But to find the amplitude, it's the average of the distance between the two, the highest and lowest. So you subtract to get that distance, and then you divide it by 2, that's the amplitude. Okay, and what they do here, they go through and they graph it as they're doing it. They'll change this graph so it will end up looking like this. Okay, and so they talk about the vertical shift. Well, you take the largest data value and you add it to the smallest data value and you divide by 2. So you're finding the halfway point between the highest and lowest value, not the distance between the two, but the average. What is that? What is that point between? And so that is your new x-axis. So that tells you what you're adding or subtracting to the function. All right, so we're going to be adding 52.1. And so they had the 22.1 sine x plus 52. So now this kind of lines up with the high and the low of the points. And now we need to think about, we did the vertical shift, we did the vertical stretch and the vertical shift. Now we need to look at the compression, or the compression or stretch in the vertical, in the horizontal, and the phase shift. Okay. So it needs to be shifted horizontally and stretched horizontally. Because the highs don't line up. All right, it's easier to find the horizontal. What is that word? The horizontal stretch. Factors first, since the temperatures repeat every 12 months, so the function has a period of 12. So 12, and we're dealing with the sine function, so 12 equals 2 pi over omega. Right? 12 equals 2 pi over omega. You switch positions with the 12 and the omega, and you get omega equals 2 pi over 12, or 6 pi. So the period is 6 pi. Pi over 6. And so that's what you end up multiplying x by. And so now it kind of sort of fits what's going on here, except it's been shifted. So we want to find out how much we need to shift this to the right or to the left. I don't know. So
Okay.
Thanks, sir.
we're over time anyway, so. Yeah. So now I get to erase the board. Oh, man. That is so frustrating when that crap happens. All right, I'm going bye-bye.
Oh, that's
Oh, Alejandro, need to put your name in chat. Because if you don't, I'll count you absent, even though I know you're here. Alejandro. Oh, I hit the wrong button. What is that doing?